Welcome to today's presentation on our analysis of the e-commerce consumer behavior dataset. In this study, we aim to explore key patterns and insights that can drive predictive marketing strategies. By leveraging the various data analysis techniques and machine learning models, we seek to uncover trends that influence consumer decision and improve business outcomes. During this presentation, we will walk through the datasets and its features, data cleaning and pre-processing steps, exploratory data analysis, key findings and insight, predictive model and its evaluation. Our goal is to demonstrate how the data can be effectively to enhance marketing strategies and drive business growth. Let's dive into the analysis. This script is a Kaggle notebook template that sets up Python 3 environment for data analysis. It imports common libraries like NumPy and Pandas for numerical and data processing tasks and demonstrate how to list files in a Kaggle provided input directory which datasets are stored. This script also highlights writable directories like Kaggle Working for saving outputs and Kaggle Temp for temporary files. It serves as a starting point for loading, exploring, and analyzing datasets in a Kaggle projects. This script imports essential Python libraries for data analysis and machine learning. It includes Pandas for data manipulation, NumPy for numerical computation, Seaborn and Matplotlib, PyPlot for data visualization, and sklearn for machine learning tasks. Specifically, it imports k-means clustering from sklearn cluster. Additionally, warnings are supposed using warnings that filter warnings ignored to maintain a clean output during execution. This script loads an e-commerce dataset into a data frame using Pandas read_CSV function. The data file path points a Kaggle input directory. After loading, the data is stored in a main data and copy of it is saved as a DF to preserve the original dataset for reference or backup during analysis. Displaying DF will show the dataset contents for initial inspection. The df.isNull.sum method checks for missing values in the dataset. It calculates and displays the total number of null missing entries for each column. This is useful for identifying columns with missing data that require cleaning or imputation before analysis. The df days since prior order unique method retrieves the unique values in the days since prior order column of the dataset. It provides an array or distinct values, helping to understand the range or categories of data in that column, which is useful for analysis or feature engineering. This code handles missing values in a dataset. It iterates through each column in the data frame, and if the column data type is float 64, it helps all null missing values in that column with -1. This ensures that missing values are handled without affecting a non-floating point columns, preserving data integrity for further analysis or model training. This line converts the days since prior order column in the data frame to the int64 data type using the asType method. It ensures that the column contains integer values instead of floats, which is often necessary for consistency, memory optimization, or compatibility with certain algorithms or operations. This code loops through each column in the data frame and checks the numbers of unique values in each feature. For columns with fewer than 22 unique values, it prints the number of unique values along with the specific values themselves. For columns with 22 or more unique values, it only prints the count of unique values. This is useful for understanding the distribution of categorical and continuous variables in the dataset.
So dito po makikita natin yung code na group equals df dot group by parentheses product ID, product name, department, close parentheses, reorder, Ang function po niyan is pinagsasama-sama po yung kada column, yung product ID, yung product name, tas kung anong department, tsaka yung reorder niya. Ito po makikita po natin yung output sa baba. Then next is group is equals to group by group product name sum reorder sort values ascending equals to false. Bali, pinagsasama-sama niya po yung mga reorder na tas nakabukod na po, nakasort na po. SNS dot set style dark grid. Tas PLT dot Y label number of records font size equals to 13. Ibig sabihin yung Y label niya yun yung name ng record. Ito siya yung nakalagay naman ng name of record. Tas yung PLT dot X label most order product. Ayun siya yung sa baba naman. At ito yung output niya. Yan. And next, group equals DF by group. Reorder, product, ID, aggregate, count, reset index, group ratio, group product ID, apply, lambda x, group product ID sum. Bali, ito siya, pinagsama-sama niya, kinolekta niya yung reorder tsaka product ID ratio, tapos ito yung mga lumabas na result. And another graph, group equals to group by reorder sum product ID sort values ascending to false. SNS that set style white grid po yung gagamitin niya. And PLT that Y label number of products, PLT that X label reordered, PLT that tick label underscore format style equals to plain Y axis. And ang function po nun, ito para makagawa ng product ay ng graph. Yung Y label na name of product, ito po yung function niya. Yung mga may 2,000 to 12,000. Tapos yung X label naman yung reorder. Ito siya, 0 to 1. And next is CLST underscore PRD equals to PD dot cross tab open parenthesis DF user ID DF department and close parenthesis. Bali dito naman siya, nakahilera ng patagilid, department, alcohol, babies, bakery, mga ganun. User ID, ito mga to. K means equals to K means N cluster equals 6, random state 540, K means equals to K means dot fit X train, print the cluster R, K mean label, print the inertia is equals to K mean inertia. So ito na-print yung cluster, ito ang lumabas 0, 2, 4, dot dot 0, 2, 4. Yung inertia naman niya is ito, yung mga number na nandyan sa baba.
So, from image 1 shows the setup of running PCA on the data, including importing PCA and linearities from relevant libraries, defining the data variable X and Y now, setting the target cluster names. So the code then performs PCA with two components and transform the data. It also calculates the explained variance ratio for the first two components. From image 2, displays a scatter plot visualization of the first two principal components with the data points colored by their cluster assignments. And the key insight from this analysis are PCA was able to capture the main structure of the high-dimensional data in just two components. The clusters are clearly separated in the PSA projection, indicating good separability. So overall, this PCA approach effectively reduces the dimensionality of the datasets while preserving the underlying cluster structure. The visualization helps interpret the results. Next is the code performs principal components analysis, it's the PCA, to identify the optimal number of components that explain 95% of the variance in the datasets. So the resulting graph shows the explained variance ratio decreasing as more components are added, with around 9 components needed to capture 95% of the variance. So the code is running principal components analysis of PCA with 9 components and a random state of 453. It then runs a k-means clustering algorithm on the transform data from the PCA. So the output shows a secret plot that visualizes the inertia of explained variance ratio for the PCA components. The plot displays the relationship between the number of PCA components and the inertia score. As the number of components increases, the inertia score decreases, and indicating the first few components explain the majority of the variance in the data. The script plot can be used to determine the optimal number of PCA components to use the further analysis of modeling. And the elbow of the curve, where it starts to flatten out, is often used as a guideline for selecting the number of components that capture a significant amount of the variance. So this code naman is performing a PCA, which is the principal components analysis, with 9 components and a random state of 453. So it then runs a k-means clustering algorithm on the transform data by creating 5 clusters. So the code then adds the cluster assignments back to the original datasets and creates a cluster category column, assigning each data points to a cluster number 1 through 5. So the image shows a table with various product departments, alcohol, babies, bakery, and etc. The counts for each cluster category for each user ID. This suggests the code is being used to analyze purchasing patterns or behavior across different product departments.